Alright, 3.4, proofs with parallel lines. So we're going to use some of the knowledge that we've used so far to help us prove that things are parallel. So here's a reminder. If any of the following are true, the two lines must be parallel. So first, the alternate interior angles are congruent. The alternate exterior angles are congruent. The consecutive interior angles are supplementary, or the corresponding angles are congruent. See, so if we have any one of those four things, we know the lines are parallel. Or we could say, if the lines are parallel, then these four things must be true. So if we take a look at this problem, alright, we have given L and M are parallel, and that angle 2 and 4 are congruent. We need to prove that angle 4 is congruent to angle 3. So since we know that angle 2 and 4 are congruent, basically what we want to do is we want to prove that angle 2 and angle 3 are congruent. Because if 2 and 3 are congruent, that would mean that 3 and 4 are congruent. Okay, because 2 or 3 are the same, then 3 and 4 are the same. So, we're going to say, since L is parallel to M, angle 2 is congruent to angle 2, yeah, sorry, I said that wrong. Angle 2 is congruent to angle 3 because they are alternate interior angles. So if you remember, if we come back here, see if two lines are parallel, we know that their alternate interior angles are congruent. Okay, so we know that angle 2 and angle 3 are the same because it was given to us that L and M are parallel. So 2 and 3 have to be congruent. And since it was given to us that angle 2 and angle 4 are congruent, we can use the transitive property. So we're going to say the transitive property, which we haven't talked a lot about, but the transitive property states that if 2 and 3 are congruent, or if 2 and 4 is incongruent and 2 and 3 are congruent, then 3 and 4 must be congruent. So angle 3 is congruent to angle 4. So let me repeat that in case it didn't come out right. If 2 and 4 are congruent, and if 2 and 3 are congruent, then we know that 3 and 4 must be congruent. So we proved that 2 and 3 are congruent because of alternate interior angles. And since these two are congruent right here, and these two are congruent right here, 3 and 4 also must be congruent. So that's what we just proved. Okay, so let's try another one. Given L is parallel to N, prove that the measurement of angle 3 plus the measurement of angle 6 equals 180 degrees. So we're going to say, since L is parallel to M, we know that angle 3 and angle 6 are supplementary. Okay, we know that because if you look back at our four theorems that we talked about, it says right here the consecutive interior angles are supplementary. If you look here, so I guess I need to state, because they are consecutive interior angles. So since they're consecutive interior, and we know it was given to us that L and N are already parallel, we know that these two have to equal 180 degrees because of one of our theorems. Okay, so basically you're just going to be using your theorems to help you prove if things are possible or not. And on your assignment, it's possible that you're going to get one that can't be proven that they're parallel. For example, notice in our theorems, it doesn't mention anything about vertical angles. So we know that vertical angles are congruent. However, this doesn't help us, this doesn't tell us whether two lines are parallel or not. So some of your assignments, or some of your problems on your assignment might show you a problem with vertical angles and say, are these parallel? And we can't prove that. We can't prove that two lines are parallel if all we know is that your vertical angles are congruent, because it's possible that you have congruent vertical angles on one, like on the top part of your line, but the bottom doesn't necessarily mean the bottom line is parallel. Okay, so you're just going to be solving and working with your theorems today to help you know, to help you understand and figure out whether lines are parallel or not.